All right, back at it again with another math video. This is going to be on the distance formula. So we're going to be finding the distance of line segments. I'm going to tie this in with the Pythagorean theorem. But first, I'm going to go through the general form of the distance formula and how to substitute in correctly the x and y value or x and y coordinates of the endpoints of a segment into the distance formula into it so that you can calculate it. Okay, anyways. So I like to use highlighters. I like to keep track of stuff. I feel like in the last, I don't know, since COVID has started, I became a lot more type A in trying to organize and explain things for students because it's been remote and I haven't been able to answer questions immediately. So organization really helps. At least I have found that. So I like to highlight one of my endpoints and then highlight the other endpoint, that, or you can just write them in different colors to begin with if you just do this in blue and this in red or something. And so I see that what you get actually is when I substitute this stuff in is I'm going to get pieces of each point in there, okay? And what is also really important is this negative in here does not change. That sometimes magically disappears. I feel some students magically let that thing just go away, or they mistake that minus as a negative. That minus needs to be there no matter what. So when you're substituting things in, these need to be x's and these need to be y's. And if you notice, they need to be in the same order, right? So that's why it's nice to color coordinate them is I can see that the first things need to be blue and the second things need to be, I don't know, pink, all right? If you don't remember that way, you need to remember that the first, like you don't mix and match. This wouldn't be x sub 2 minus x sub 1 and then y sub 1 minus y sub 2. It's x sub 2, y sub 2 minus x sub 1, y sub 1. Or you could do x sub 1 and y sub 1 here minus x sub 2, y sub 2. So it doesn't, I could have did the pink one first, but it doesn't matter. What matters is that you're not mixing and matching, all right? Either do one point first and then the next point, or do the other point first and then the next point, okay? That'll make more sense as we go, hopefully. So the other thing that I talked about, Pythagorean theorem, that I want to tie into this is this distance formula is derived from the Pythagorean theorem. And hopefully at some point, middle school students get taught, or at least talked about the Pythagorean theorem. And the Pythagorean theorem has to do with right triangles. So if I was to make a right triangle out of this line segment, so that symbol means that that's a right angle, which makes that a right triangle. And if I was to make, this is now, you see a right triangle. And the Pythagorean theorem is the leg squared. So first off, on a right triangle, you call this a leg, and you call this also a leg. And then over here you have the hypotenuse. All right? So the Pythagorean theorem says leg squared plus b squared, or one leg squared plus the other leg squared, equals the hypotenuse squared. So what you get, and usually we do A, B, and C. C is always the hypotenuse, and what we get is you get a squared plus b squared equals c squared. So that's the Pythagorean theorem, all right? But D, this distance formula, the whole point of this distance formula is to find the distance. It's to find the length of from A to B. In the Pythagorean theorem, D is C. So C and D are equal to each other. So you can imagine that at some point this C we might substitute for D. So if I wanted to solve for D, you see how this is solved for D? This isn't D squared. This is just D. Well, something, I don't know if you ever were taught this, but in order to cancel out a square, in order to invert a square, you do the opposite. The inverse operation of squaring is to take the square root. So you take the square root of both sides. And what you get is the square root of a squared plus b squared equals c, because these cancel out because they're inverse operations. Looking really similar right now, right? Looking really similar. We now have c equals, and up here we have d equals, and then we have the big square root. We also have the little squares here with an addition symbol. You see the addition symbol in the little squares? So really similar. Now, if I know c equals d, then I can do substitution. So I can also now make this to be the square root of a squared plus b squared equals d. Well, I don't like the order of that, so what I'm actually going to do is I am going to flip-flop it using the symmetric property. That's something that you might pop up in a geometry class. Symmetric property means you're allowed to flip across the equal sign so long as you don't change anything. You can just flip it. So you get d equals the square root of a squared plus b squared. So what you find here is that a is equal to x sub 2 minus x sub 1. And what it is, all x sub 2 minus x sub 1 is it's finding the length. It's a mathematical operation, right? This is a formula. Formulas are meant to plug things in and then do the operations on them to find values that we want. And what x sub 2 minus x sub 1 does is it finds this distance here. Well, I got mine backwards. I got these backwards. This should be B and this should be C. But the point is what you find here is it's calculating this distance. So this is x sub 2 minus x sub 1, which ends up being this length. And then you find, and then this over here is finding this length. So that's y sub 2 minus y sub 1. So all you're doing here is finding the lengths, and in reality, if you wanted to, you could draw a right triangle and just count it. So if you had a graph, and I'm going to do that actually on this next problem. I know that this is all conceptual and it's a bunch of letters and a little confusing, but I'm going to go through an example and I'm going to do both ways of finding the length of a line segment. So let's move on to that. But the point is the distance formula and the Pythagorean theorem are one and the same. It's just rearranged to find a specific value. So first thing I'm going to do, let's find out how long it takes me to use the distance formula to find the length of AB. All right. So we're going to call this D, right? We're finding the length from here to here. We're finding the length, finding the distance. All right, so I'm going to substitute stuff in. I got D equals the square root. I'm going to fill in the stuff that does not change. That's really important. There's certain things that do not change. Parenthesis, minus, and the square, plus, parenthesis, minus. None of that changes. All you're substituting in is right there, right there, right there, and right there. Okay, so I'm going to come up with the highlighter. Highlighter's handy. All right, I'm going to highlight this one blue, and I'm going to highlight this one pink. And I'm going to identify this one as my x sub 1, y sub 1. I'm going to identify this one as my x sub 2, y sub 2. Really important, really helpful to label which one's your x sub 2, y sub 2, and your x sub 1, y sub 1. So when I substitute and I look, okay, x sub 2, I need to substitute that in first. So this is going to be a 6. Okay, now I need to substitute in x sub 1. So x sub 1 is a positive 2. Wait. No, it's not. See, that's really got to pay attention. It's down here. So x sub 1, substitute x sub 1, that's a negative 4. X sub 1 is negative 4. Now, when you minus a negative, it's good to put a parenthesis around it. So negative 4. Oof, running out of room on that one. Got negative 4. All right, might zoom in a little bit actually. So I got the negative 4 in there. Now I'm going to substitute in my y sub 2. My y sub 2 is 2. And then I'm going to substitute in my y sub 1, which is negative 3. Again, I'm going to put parentheses around it because it's negative. All right. I've substituted in the 4 things, right? You only have to substitute in 1, 2, 3, 4 things. I substituted in 4 things. Now I begin to simplify. So I get d equals the square root of all this jazz squared plus all this jazz squared. Well, what is 6 minus a negative 4? Well, first off, a double negative becomes a positive, so 6 plus 4 is 10. And then we got another double negative over here, so 2 plus 3 is 5. All right, I did one simplification. Now let's do the next one. D equals the square root. What is 10 squared? 10, and squaring, by the way, is multiplying it times itself. So what's 10 times 10? 100. What's 5 times 5? 5 times 5 is 25. So I get d equals the square root of 125. Now, hopefully, my hope is that everybody knows at least up to the 10 squared of what that is. So I'm going to list off that, right? We got 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared equals 36, 7 squared equals 49, 8 squared equals 64, 9 squared equals 81, and then 10 squared equals 100, right? And that's 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, right? 5 times 5, 6 times 6, 7 times 7, okay? What you notice is none of these equal to 125. And if I actually do 11, so if I do 11 squared, that equals 121. And then if I do 12 squared, that equals 144. You see how it just skipped over 125? Skipped it. There is no perfect square root of 125. So this is actually the answer that I would want my students to answer with. Just that, with the square root symbol. Your answer should be the square root of 125. All right, that is the length. Okay, I don't want decimals. You don't use, if you use your calculator, you're going to get some decimals, and I don't want decimals. I want the perfect square root. Only if, like if you had, we'll save that. There's going to be some other examples. Other ones will work out. We would stop here though, because there is no square root of 125. And you can double check it, right? You can pull out your calculator. Smartphones have square root buttons too, right? A square root button's right there. So if I put in square root of 125, the glare off, square root of 125, I don't want that. I don't want decimals. So I leave it as the square root of 125. Okay. Now, what I'm going to do here is, like I said, I'm going to compare the distance formula to the Pythagorean theorem. So if I make a right triangle, there's my right triangle. All right, and I just count the squares. I'm just going to count the squares. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this side is 10. And then I go 1, 2, 3, 4, 5. This side is 5. Wow. You know what I see right there? I see, grab some different colors. What I see is that right there. I skipped a step, basically. I skipped having to do all the plugging in. Pythagorean theorem, I didn't have to do all the plugging in. I could just count the squares, and that's what goes right there. Because like I said, x sub 2 minus x sub 1 is a method, it's a formula for just finding what's the distance here. Now this doesn't work obviously if you can't count the squares. Now when you start geometry, we're letting you count squares. Very helpful if you can count squares. If this was like a decimal or a fraction, you wouldn't be able to do it. But there are times where you can do a quick trick, right? This is a shortcut. So what I get is, I get 10 squared plus 5 squared equals, and remember D is the same as C in the Pythagorean theorem, so I get C squared. Well, what's 10 squared? 100. What's 5 squared? 25 equals C squared. And then on the other example, I talked about how do you cancel out a square. The inverse operation of squaring is to take the square root. Take the square root. I skipped a step. 100 plus 25 is 125. So I get the square root of 125 equals C. What do you know? Same thing. Now, really important, guys, really important, at least I shouldn't say guys, to my students that are watching this. This is the way that I'm going to be wanting you to do this, but it's just important that you recognize that the Pythagorean theorem, goes hand in hand with the distance formula. Okay, so, ow, just kicked my desk. So I'm gonna stop at the Pythagorean theorem, I don't wanna add any more confusion if anybody's confused about that. We're gonna go to two more examples of strictly using the distance formula to solve this stuff. So let's move on away from graphing. Let's do strictly distance formula. So what I'm going to do, right, I'm going to highlight. I have my example problems. I want to find the length of segment AB, right? Find the length. That means distance, right? Find the length. That means distance. So I'm going to highlight one point, highlight my other point. I'm going to label this one x1 and this one y1, which means this one is x2 and this one is y2. All right. So now when I substitute into the distance formula, I guess I got to write the distance formula first. So d equals the square root. We get something minus something squared plus something minus something squared. So what do I substitute in? The first thing I substitute in is x sub 2. X sub 2 is 10. Next thing I substitute in is x sub 1. X sub 1 is 2. Next thing I substitute in is y sub 2. So I look at y sub 2, that's 20. Next thing I substitute in is x sub 1. Now, why am I looking at? Next thing I substitute in is y sub 1, and that is -4, which means I'm going to put some parentheses around it. So -4. All right. Now I substitute in my 4 things. So now I simplify. So d equals the square root. of something squared plus something squared. So 10 minus 2 is 8. 20 plus 4, double negative, so 20 plus 4 is 24. All right, well, this, I'm going to pull up my calculator because this is pretty big. I'm going to get some big numbers. So I'm going to get d equals the square root of 8 squared. I know that. 8 squared is 64. I'm not going to lie, though. I do not know what 24 squared is off the top of my head. So 24, then there's a little, I got a little square button over here, so I can do 24 squared. And that equals 576. 576. So I'm going to add to that 64, so plus 64. So I get d equals the square root of, what is that, 640. Now I'm going to double check. So this is when I double check. So square root, 640. I get a decimal. I get a decimal. I don't like a decimal. So this is where I'm going to stop. Stop. All right. I'm not going to answer with that. I do not want, right? I do not want d equals 25.298 to whatever else happens after that, right? I want this. No decimals. All right, stop there. All right, that goes to my students. I don't know what other teachers would want, whether they round to 2 decimals or simplify the square root. All right, one more. So again, I write down the distance formula. I got d equals square root. Since it's out of view, I'm going to write out the entire general one, which is x2 minus x1 squared plus y sub 2 minus y sub 1 squared. All right. Then I write it all again. A lot of writing of formulas, right? So we get our minus squared plus minus squared. All right. So we are going to, it's going to be 1 point. It's going to be my other point. I'm going to identify this as my x1, y1. This is my x2, y2. So my x sub 2 is the first thing I substitute in. So that is negative 2. Then I'm going to substitute in x sub 1, and that is negative 5. Then I'm going to substitute in y sub 2, and y sub 2 is 0, so 0. Then I'm going to substitute in y sub 1, and y sub 1 is 4. All right, so then I simplify. So d equals the square root, something squared plus something squared. So negative 2 plus 5, double negative, so plus 5. So negative 2 plus 5 is 3. And then 0 minus 4 is negative 4. And then I get d equals the square root of 3 squared. 3 times 3 is 9. Plus negative 4 squared. So negative 4 times negative 4 is 16. I'm going to move up here. So then I get d equals the square root of 25, because 9 plus 16 is 25. And hopefully everybody knows what the square root of 25 is. 5. So do you see the difference? This time I didn't stop at the square root because that doesn't have any decimals. All right. So if you get a whole number, you answer with the whole number. But if you get a decimal, then you answer with the square root. Okay. And I'm actually answering these incorrectly. What I should be saying is, because I'm answering for segment AB, is AB equals the square root of 640. And then here I should be saying RT equals 5. Okay? So these would be my actual answers. I think this video is pretty darn long. So I'm gonna end it there. I'm assuming I'm probably gonna need questions from my students, but I hope this was a good starting point, a little introduction. And I'll probably be making some more videos on it. At least some more example problem videos on it of just going through more examples. That's what math is, right? Tedious, gotta do it over and over again. All right, so thank you for watching. I hope this video is helpful. If not, let me know. All right. Peace out. I don't know.